Red eye? Okay, so here we have some bell-shaped distributions based on some data. And this is a standard distribution. It's also called a normal distribution, or it's called a Gaussian distribution. Gaussian. And it's all defined by one simple function, which we don't ever need to know what it is. The point of this bell curve is that it's got two properties. It's got a peak value, which is also equal to the average value. And in case of statistical distributions, what we mean by average is actually most probable value. And there is a width around these curves. And that width represents the variation of the data around the most probable value. And that is called a dispersion in the class notes. Or in that term dispersion, which means variability around the mean, is the same as the standard deviation, which some of you may have heard about before. Again, it's a measure of the variability about the mean. If we had a bell-shaped curve that looked like this, it's got low variability. If we had one that looks like that, it's got high variability. That variability can arise because of the intrinsic thing that you're measuring in nature is highly variable, or that your measurements suck. They have lots of random error in it, and the random error component has served to broaden the variability. We will deal with that issue later. For now, I just want to get across one and only one fundamental point about why you would even use statistical distributions. And best focus on the bottom one is that probabilities map onto these percentages. So in other words, within plus or minus one standard deviation, all of the data values in the curve, of all those data values under the curve, 68% of them occur within plus or minus one standard deviations. 96% of the data occurs within plus or minus two standard deviations. And therefore, if you are determining probability values from observed events, for instance, you can say, okay, here I have a most probable value of 500. What is the probability of you observing a data value of 700? Well, 98% of the data is contained within a value of 700, so the probability of you observing an event which has a value of 700 is 2%. So that would be a somewhat rare event. And so this is the value of this curve. It tells you the probability of an event occurring within the previous established distribution of the phenomena. So you can apply this to weather events, to hurricanes, to all kinds of environmental things, with the most important goal of establishing, is the event expected within the distribution, or is it rare? A 1,000-year flood, for instance, means that there's a probability of 1 in 1,000 years of that flood happening. And in terms of the bell curve, you'd have to extend that out to about 3 standard deviations, because plus or minus 3 standard deviations contains 99.97% of the data. So in other words, let's finish with a simple example. Suppose that you were measuring something and it's been established that this phenomena has an average, which is usually called x bar, equal 20. And from those measurements, you've established a standard deviation or dispersion, usually represented by the Greek symbol sigma, equals 7. And now, some event rolls around which you observe that has a event, single event, has a value of 42. And you want to know, should I have expected that event to occur? Well, we know the answer to that. Okay? So within the range 20 plus or minus 7, we know that 68% or 2/3 of the data have data values with that. We know that 96% of the data is contained within plus or minus 14, 2 standard deviations. Okay? We know that 99.97% of the data is contained in 20 plus or minus 3 standard deviations, which is 21. Okay? So in this case, a value of 42 is more than 3 standard deviations away from the mean. So that's a very unexpected value if it occurred by random chance, and therefore it represents a significant event whose existence was not caused by a random event from a normal phenomena, but a change in the phenomena itself. That's why you use these bell curves to establish whether external conditions have changed in terms of the event rate of a phenomena.